Good morning, children. This is Shaivalsas speaking. Children, as we have been dealing with the chapter direct and inverse proportion, so right now we are going to start exercise 13.2, which is about inverse proportion. In the previous exercise, we had a discussion on how to deal with direct proportional forms, in which we had dealt with two aspects in which if one aspect increases, other one also gets increased. If one aspect decreases, other aspect also gets decreased. So in such comparisons comes under direct proportional form. So we have already completed that exercise, and we learnt many things from there. And right now we are going to start exercise 13.2, that is inverse proportion. So inverse proportion is what? Like the very first thing we have to understand the primary concept of inverse proportion. Inverse proportion is when one aspect, when we are comparing two interrelated aspects, if one aspect increase, other one decrease. If one aspect decrease, other one increase. Such comparisons comes under inverse proportion. Now, what are the general common real life examples can be given in order to explain inverse proportion? For an example, like in a factory, the number of workers are 50 and they are doing a job, they are completing a task. They require, suppose, 5 days to complete that task. 50 workers will complete the task in 5 days. If the number of workers, if the number of employees gets increased out there, if I allot more number of workers out there, so obviously the work will be finished before the set time. The work will be finished before the set time. If the number of workers decreases, suppose from 50 now there are 30 workers, so obviously the job will be taking much time. Rather, it will be not finished. It won't be finished at the same time. It will take more than that, more than 5 days. Okay, so such situations are known as such situation comes under indirect proportion. Indirect, these situations can be defined using indirect proportion. There are more examples can be given. Suppose for a fixed journey, for a fixed distance of journey, if the speed of the vehicle increases, then the journey will be completed within less time. If the speed of the vehicle decreases, so naturally the journey will be taking longer. So this is in inverse proportion. So here in this exercise 13.2, we'll be dealing with more examples, and we have to identify whether this is in direct proportion or inverse proportion. So the first question is the number of workers on a job and the time to complete the job. Obviously, the number of workers and the duration of the job, these are in inverse proportion. As the number of workers will increase, the task will be finished before the set time. So this is in inverse proportion. The time taken for a journey and the distance traveled in a uniform speed. This example is already been given in this video. That if the speed is uniform, time taken for a journey and distance traveled. No, this is not in inverse proportion. This is in direct proportion, because here the speed is fixed. The vehicle is running on uniform speed. So if the vehicle runs for a long period of time, so of course it will cover more distance. It may cover more distance. If it runs if it runs for a less period of time, so obviously it will cover less distance. So the speed is uniform over here. So for that situation, this is not in direct. This is not in inverse proportion. This is in direct proportion. Area of cultivated land and the crop harvested. Area of the cultivated land and the crop harvested. So this situation is if area increases, if area increases, then obviously we can harvest more crops, or more the crop production can be increased. If the area decreases, if area of the cultivated land decreases, so obviously we can produce less number of crops, less amount of crops. So this is in direct proportion. The time taken for a fixed journey and the speed of the vehicle. Time taken for a fixed journey and the speed of the vehicle. Yes. If the distance is fixed, as it says, the fixed journeys, when the distance is fixed, if the speed of the vehicle increases, time will be taken less. If the speed of the vehicle decreases, time will be taken more. So this is in inverse proportion. The population of a country and the area of a land per person. Population of a country and the area of a land per person. See, we cannot increase the boundary of a country, okay? We cannot increase the land size. For a country, the land is fixed. I mean to say, the land size cannot be neither can be increased nor can be decreased. So if population increases, so obviously the place allotted, or the land allotted for a one person will be decreased. There will be more crowd. So the space for one person will be decreased if the population increases. Simply can be give an example. Suppose in a classroom there is a facility of 40 children can sit in one classroom. There are, suppose of benches, there are 40 children can sit in one classroom. If the number of children increases in that classroom, that particular classroom, so obviously you have to in one desk, suppose 2 children are sharing one desk, so at that time 3 children have to sit in one desk. So your space is decreasing out there. So this is in inverse proportion. Children, question number 2 is about in a television game show, the prize money for 1 lakh is to be divided equally amongst the winners. To complete the following table and find whether the prize money given to an individual winner is directly or inversely proportional to the number of winners. Children, one thing that we have to understand very nicely is, when the prize money is fixed and the number of members are increasing, so obviously per head the amount which will be distributed, that will be decreasing. Amount was 1 lakh. When the amount is 1 lakh and one recipient, if there is one winner, so that one individual will get the entire 1 lakh amount. If there are two winners, so it will be divided. Now each individual is getting 50,000. Before, one person was getting 1 lakh. Now it's 50,000. So the amount is decreasing. What about for 4 winners? If I divide 1 lakh by 4, it will be 25,000. Now each individual will get 25,000, 25,000, 25,000, 25,000. As the number of winners are increasing, it's getting divided equally, or the amount is getting decreasing. For 5 winners, 1 lakh divided by 5 is 20,000. Now for 8 number of winners, 1 lakh divided by 8, 12,500. Now for 10 winners, 1 lakh divided by 10, it's 10,000. Now for suppose 20 winners, 1 lakh divided by 20, that is 5,000. So what we can observe from here, we can observe that the amount is decreasing as per at the rate of when the number of participants or the number of winners are increasing, the amount is decreasing. The amount to be distributed, that is getting decreased. So obviously this is in inverse proportion. So children, this is how we have to deal with this concept. I gave a little concept of inverse proportion. We will be dealing with more questions of this exercise. So children, I request everyone to come and join my live class. See you all in the live class. Till then, thank you so much children. Bye bye, take care, and please do solve these questions on your copy. These questions, question number 1 and question number 2 will be marked as your homework. Thank you so much.